Everyone. In yesterday's class, we have discussed about the what is solar energy, what is solar radiation, how we can measure the solar radiations, and what are the various applications that we will use solar energy. And today's class, we are going to discuss about the solar appliances. So, in other sense, these are the solar applications where we are going to utilize the solar energy that we are going to discuss. So coming to the solar appliances, broadly we can classify them into the two categories. So we well know what is the solar photovoltaic systems. So which are simply we can call it as the solar panels. We will use this one to convert the solar energy into the electricity. So generally using the solar panels, it is well known to us. Using the solar panels, what we will do is we'll collect the solar energy. It is incidented on the solar panels that will convert this solar energy directly into the electricity. So that generally convert the direct current that we will store in the batteries, and using this DC to AC converter. After converting into the AC current, we will use in our houses using the solar panels. It is the one of the applications that using the solar photovoltaic cells, that we can call it as the solar photovoltaic effect. The other one is the solar thermal systems. So that is the best example is the solar water heaters. So what we will do here? So here we will have the solar collector, thermal collector. The main aim of this one is to collect the from the solar energy, solar radiation. We will collect the heat. So we will collect the heat here. So we will collect the heat energy, and that will transfer to the fluid, either water or air. So those systems we call it as the solar thermal systems. Okay, these are the two major applications that we can divide. The any application of solar energy will fall into these two categories only. So in today's class, the mostly we are going to discuss about the solar thermal appliances. Especially we can call it as the solar thermal collectors. So what are the solar thermal collectors? What are its working principle? That we will see. The firstly we are going to see about the how the solar thermal energy system works. The any solar thermal connector, the basically it consists of the block body. Okay, so which is coated with the completely in black color. So it will collect the solar energy. Okay, so what we are doing here? So we will expose the this dark surface to the solar radiation. So we will expose this black body to the solar radiation. So it absorbs that solar radiation. We all know that black body is a good observer. That's why we are using a black coated material or black body to observe the our solar energy. And we divided this one, this solar energy. Here we can see the two energies are coming. Okay, these are both are the solar radiations. So as we discussed in the last class, this whatever the radiation coming from the sun directly, we call it as the beam radiation or direct solar radiation. And whatever is coming from other side, generally it is coming from the clouds. Okay, it comes from the clouds. This radiation we call it as the diffusive radiation, that is generally reflected from the clouds. That both the solar radiation will be absorbed by this black body. Then what it does? Let's see. So what we'll do is a part of the absorbed radiation. So whatever the radiation observing here, that will be transferred to a fluid like air or water. So it absorbs the solar radiation. From that solar radiation, a part of it. So it may not transfer the all the 100%. So it transfer the a part of it. Maybe it may be the 60% or 70% or 90% based on the how much of coating and is there. So that we will transfer to the fluid like air or water. Either we can transfer to the air or water. Generally, in contact with this black body, we will have the tubes. Okay. Generally, suppose if you take the water, these tubes are generally we will use the copper tubes. Okay. Why? Because we will use the copper tubes is so copper is the very good conductor of heat. So for suppose if you are sub transferring the this heat to the water, suppose at one end we'll input the cold water as it moves from one end to the other end. So it absorbs the heat from the block body and the water is gets heated. So eventually it will convert from cold water to hot water on the other end. This is the solar thermal collector's working principle. So basically what is the solar thermal collector? Now we can define. So what we are doing, basically we are collecting the heat from the sun and transferring to the water. So what we are doing, we are exchanging the heat. So how we are exchanging? Using a device. So basically the solar thermal collector is a heat exchanger device which converts the solar energy into heat energy. So that is the definition of the solar thermal collector. What it does? So solar thermal collector is a heat exchanger device which converts the solar energy into heat energy. Other way, we can also define it as the device which is used to collect the heat from solar radiation. Other words, we can how we can defining it. It is a device that will collect the heat from solar radiation. Okay, that is the we can also define as the solar thermal collector. We can use the both definition. So what is the main function of solar thermal collector? Is that is collect the heat from sun solar radiation. The main function is collecting the heat from solar radiation. That is the main function of the solar thermal collector. So based on the temperature that can be attained using the thermal collector, we can classify it as the two types. Okay. So on the what basis we are classifying them? Based on the how much of temperature that we can attain using this thermal collectors. Those are one is the flat plate collectors. So where we have the complete flat plate. Okay, this we will discuss further in the coming slides. And next one is the concentrating collectors. Basically, this works on the different systems. It will reflect the solar energy. So that we will discuss in the coming slides. Now moving to the flat plate collectors. So as I mentioned, based on the temperature we are classified, these flat plate collectors we will use for the low temperature applications. Generally below 100 degree centigrade. So whenever we are using the flat plate collectors, that we can attain the maximum temperature is 100 degree centigrade only. Okay. So again, these flat plate collectors we can divide into the two categories. One is the liquid heating collector. So where the best example is the water heaters. Another one is the air heating collectors. These air heating collectors normally we don't use in our houses. Okay. Basically we will use in the industries or hotels. We can use this hot air for the circulation and keeping the air conditioning systems. So now we are going to discuss about the construction of liquid heating collector or liquid flat plate collector or water heater. So here you see the diagram of the liquid heating collector. It is the generally the front view that we are seeing here. Okay, the major components here you can see is the one is the casing. This is the outer body. From all this body, we can call it as the casing. Then we have the absorber plate. Here you can see the block plate from here to here. This is the absorber plate. On the top of that absorber plate, we will have the transparent glass covers. Here you can see the two glass covers are there that we are using to transfer the heat to the block body. Then we have the insulating material. Here you can see the thermal insulation is there, so which avoids the heat loss from the surrounded observed heat. Next, we have the fluid passage tubes. Here you can see the these circles will show the fluid passage tubes. Suppose if the cold water enters from this end, this will move in the tubes, and at the end we will get the hot water out. Okay, this is the major constructional features of the flat plate collector, that is liquid. Here you can see the structural view of the flat plate collector. So here you can see the clearly the view of the this flat plate collector. So you can see the top, at the top you have the transparent glass covers, and then at the this one is the completely absorber, block coated absorber, and then we have the pipes which in which the water is going. Here you can see the aluminum casing is there at the bottom, and then this yellow color is indicating the insulation material. And as I mentioned, here you have the copper pipes. So basically we'll go the input of water from this end, and we will get the hot water at the other end. So now coming to the working principle, how it works. We already discussed in the previous slides, like the what is the working principle of thermal collector. Almost the same principle here we will use. So what we are doing, we'll exposing the collector to the sun, that is the radiation, especially beam and diffusive radiation that passes through this glass covers and reaches to this black body. So whatever the radiation observed by the plate, which is with black coated paint, we coat with the black paint, so that will absorb the solar radiation incidented on it. The fluid tubes which are connected to observer plate, as I mentioned, at the bottom of the this observer plate, we have the fluid tubes and absorb the heat and transfer to the water passing through the tubes and gets heat. As I mentioned, suppose cold water is entering here, it will transfer as you moving the water from one tube to the other tube. So the heat will be transferred to this water through the tubes. That water will be gets heated. So the hot water collected from all the tubes flows into a storage tank. So whatever the hot water will collect, that will store basically into a storage tank, hot water storage tank, which is insulated completely. Why we are storing this hot water is the basically the daylight during the daytime we will heat the water, and when we require this hot water basically in the night times or in the early mornings. So for that we have to store this water for a period of time. So if we store in a normal storage tank, eventually heat loss will occur and water will be cools down. So in order to avoid that one, what we are doing, we are storing in an insulated storage tank where we don't have the any heat loss. So whatever the temperature of the water, it will be sustained for a period of time. So what are the insulation material we will use? So that the generally paddy husk, sawdust, glass wool, that will be used to avoid the loss of heat by conduction. So this basically this thermal insulation will contains the either polyester or sawdust or glass wood. So which are the good thermal inhibitors or bad conductor of the thermal energy we will use to avoid the heat loss from the conduction, because these tubes are in direct contact with this insulation material to avoid the heat loss. And next, to avoid the re-radiation, we'll use the good absorber coating, because on this block body, if you don't have the good coating, good block thick coating, there may be the chance of radiating the energy from this black body. To avoid that one, what we are doing, we are coating with a good absorber coating, which means we have to use the very good thick black color that will absorb the whole heat. Next, to avoid the convective loss, there may be the some convective loss will occur. So that to avoid that one, what we are doing, we are minimizing the air gap between the glass covers. So here we are using the two glass covers. So there is, you can see that there is a gap is there between the glass covers. If this gap is more, the convective losses will be the more. So to avoid the convective losses, we will reduce this gap between these two glass covers is to the minimum possible length. But we don't keep them in contact. We have to keep them some spacing, that gap should be minimum to avoid the convective losses. So what is the temperature that we going to attain by this liquid heating collector? That ranges from 40 to 100 degrees centigrade, depending upon the intensity of the solar radiation. That further also purely depends on the day of the sunlight, especially on the duration and intensity of the sunlight. Okay, if the day is very bright, if you have the high temperatures, we can attain the hot water with the 100 degrees centigrade. The day is not much of high temperatures, so we can attain around the low air is the 40 degree centigrade. In the cloudy days, we may not get that much of heated water. So it should be clear, sunny and high intensity solar radiation should be available to get that good amount of heat energy we can observe or we can harvest it. So how we can going to arrange it one? Usually held tilted in a fixed position on a supporting structure. We'll keep on a supporting structure in a tilted direction. We don't keep it as a flat direction. You can see here. So there is a fixed stand is there here, and we keep some angle with the horizontal. So if you take this one as the horizontal, so there is the some angle that we keep in order to absorb the solar radiation. Okay, these all are solar thermal collector. So the one end, so see, we are giving the cold water here, and that moves, and again hot water will collected, and that we can use for the showering or whatever it may be purposes. Okay, that is the working construction and working details of flat plate liquid heating collector. Now we are going to discuss about the working of air heating collector, or simply we can call it as the solar air heater. Okay, coming to the constructional details, so very simple, similar to the completely flat plate air heating water heating collector, but the similar difference is we will have the, you can see here we have the only one glass cover will be there. So instead of two glass covers, we will have the one transparent glass cover, and we will have the one absorber plate, and one is the airflow inlet will be there, and then we will have the insulation material. Okay, so that is the, then we have the, here you can see the supporting stand at the bottom. Okay, we will have there the bottom supporting stand to hold this air heater. So okay, so what we have again, transparent glass covers are there, absorber plate is there, and there is the gap is there. There is no, we are not using any pipes here, just we are creating a gap between the insulation material and the thick black body. So in order to flow the air. So here you can see at the bottom, the cold air is entering into the this place space, and as getting heated, as going move outward, it is getting heated, it moves outward. Okay. So that is the solar air heater. Here you can see the on the large scale how it is performed. So as I mentioned, we can use for the room conditioning. So like what we are doing is we are collecting the cold air and it will move through the air heater. Okay. As moving from the bottom to the top, it gets heated, and the heated air will be either we can directly send to the rooms to get heated, or we can send a device to heat the water also. We can circulate this hot air and we can also heat the water, and we can distribute into the different rooms either for the shower purpose and whatever the uses that we can use. Again, here also working principle is the same. So as the temperature falls on the black body, that absorbs the temperature and that transfer to the air. So the heat observed by the observer plate is transmitted to the air drawn into the collector. So whatever the air drawn into the collector, to that air will transfer this temperature. So why we are seeing air out at the top and air is bottom is the cold air will have the general high density that will enters from the bottom. At most it's get heated. As the temperature increases, air temperature, its density will decrease. It automatically moves upward direction, and the air will take the hot air at the upper end of the heater. The hot air leaves the collector to a storage tank for further use. As I showed in the previous slide, we can store in the storage tank and then we can use in the for different purposes, either water heating or room heating or whatever you need. So if the size of the collector is large, this what we will do is we can use a blower to draw air into the collector and transmit the hot air to the driver. So suppose if the small air heater, suppose we are using on our homes, it will be a little bit small in size, so the automatically air will circulate. But in case of in the any hotels or in companies, industries, we are using these aerators, that in that time we will use the in the large scale to generate the more heat. In such cases, we have to input the more cold air, but it is naturally will not occur. So in that case, what we have to do, we have to use the blowers to blow the air into that air gap so that it will be connected, and then again we will draw the hot air to the driver. And most favorable orientation of a collector. So because we have to keep on certain inclination aerator, because to attain the gravitational flow of the air the possible with the highest rates, what you have to do, we have to keep the certain inclination. What is that inclination is that should be equal to the latitude plus 15 degree centigrade. Suppose in this area our latitude, let's say 60 degrees is the our latitude. So with the horizontal. So in that case, we have to keep an inclination of 60 plus 15 degrees. That is the 75 degrees in inclination we have to keep. Suppose if this is the horizontal, so we have to keep an inclination of the 75 degrees. That nearly comes like this. The 75 degrees in inclination, we have to keep the our air heater. So for the higher efficiency. The next coming to the cylindrical parabolic concentrating collector. Again, these concentrating collectors we can divide into the two categories. One is the cylindrical parabolic concentrating collectors. Another one is the cylindrical parabolic concentrating collectors. So here you can see this, the diagram. This one is the, clearly you can see the parabolic concentrating collector. So here you can see the concave shaped cylindrical glasses are there. So these are generally we will use for the reflecting, these glasses we will use mainly for the reflecting the solar energy. So these are reflective mirrors coating with the, we have the coating that will have the reflecting mirrors. Here you can see the one tube is there at the middle. So okay, though this black body is the, actually it is surrounded by this, you can see here the tube is there in which we'll get the fluid in the water and we'll take the fluid out. The pipe will be, one pipe will be there. Over the pipe we will have the, this tube, black coated one. So what will happen here is these observable plates will reflect the solar radiation to this, toward this black body. So whatever the solar radiation received, these glass covers will reflect with the higher reflection rate. So it will increase the intensity and that will reflect to on this black body. So it is basically a tube. So one end will supply the cold water. The eventual, while the water moves, it will become the hot and it will get the hot water outside. So we can discuss this again. So what happens here? The radiation coming on concentrator, as I mentioned, coming on concentrator is diverted to absorber tube, so which is covered with the glass tube to avoid the re-radiation loss. As I mentioned, we will have the good observable plate here around this one, that is in the black color. Over the pipe towards that one, it is diverted. The heat from the observer tube is transmitted to the fluid passing and gets heated. So inside fluid will pass, that fluid will be gets heated in this case. The direction of concentrating is changed with the sun movement by providing a single axis track. So in the previous pixel flat plate collectors, we have to fix at a certain angle and the pixel position. Whereas here, we can divert this direction of these plates along the direction of the sun. Here you can see the previous slide. So there is the handle is there. So using this handle, we can rotate this. Suppose it is placed now this direction towards this front direction, like this direction. So we can, using this handle, we can divert this into the another direction. So we can move towards this another direction also based on the sun rotation. So that is the one of the advantages of this concentrated parabolic collector. And we can attain the temperature is 100 to 300 degree centigrade. Okay. So whereas we can, using the flat plate collectors, we can attain a temperature of 40 to 100 degree centigrade. Whereas using this parabolic concentrating collector, we can attain a temperature of 100 to 300 degree centigrade. And next, coming to the parabolic concentrating collector. It also works the same, but the shape of the collector is the different. Okay, here you can see clearly. So this is the, basically we'll have the one reflector. So you can see that this is the good receiver first. It will receive and then reflect. So it looks like our TV antenna. Okay, you can see the shape also, the parabolic shape. So what happens is the whatever the solar radiation incident on it, so like it will be reflected towards the receiver. Here if you have the, you can see the receiver. Okay, and this also we can rotate in the 360 degrees centigrade. 360 degrees, we can rotate this one into 360 degrees. So whereas the concentrate parabolic concentrating collector, we cannot rotate in the 360 degrees, but we can rotate this one in 360 degrees where we can achieve the higher temperature. So this provides two axis tracking and is free to move both on vertical and horizontal axis. As I mentioned, you can move it on vertical as well as the horizontal axis towards three directions. The radiation received on the collector is reflected towards the concentrator. So from this, it will reflect towards the concentrator or collector. The concentrator, which is coated with the observer coating, is heated up with the concentrated radiation. This one will be heated, highly heated due to this solar radiation because it's completely coated with the black color. So basically this, the temperature we can attain, each one is the more than 300 degree centigrade. Using this collector, we can attain a temperature of more than 300 degree centigrade. Okay. So these are the different types of solar thermal collectors that we can use in the present day scenario. So coming to the overview in today's lectures, that we have discussed about the what are the basic solar thermal appliances. Broadly, we can classify into the two categories. One is the solar photovoltaic systems. Another one is the solar thermal collectors. The solar thermal collectors, we discussed about the, again, we can group it into broadly two types. Those are, what are the flat plate collectors and concentrating collectors. And again, we have discussed about the its working principle, where we will have the black body, generally the observer, and that will transfer to the heat to the fluid. Okay, then we have the fluid process tubes. Coming to the flat plate collectors, we can use only to attain a temperature of 40 to 100 degrees centigrade, usually below 100 degrees centigrade. The flat plate collectors, again, we have the two types. Those are liquid heating collector. The best examples are the solar water heaters that we will use in our homes or hostels to heat the hot water. And next one is the air heaters. We can rarely use in the homes, but those are mostly used in the industries and hotels for generating the heat and high temperatures. Then we have discussed about the parabolic concentrating collectors. Especially there are two types, cylindrical parabolic concentrating collectors, from which we can attain a temperature of 100 to 300 degrees centigrade. Another one is the parabolic concentrating collector. Using that one, we can attain a temperature of more than 300 degree centigrade. Okay, that's about the today's class.